Hi folks, this is Nat, and this is going to be your video lesson on dividing with a decimal in the divisor. So we've looked previously at just regular division and also what to do when we have a decimal in the dividend. And if we've learned nothing else from our multiplication and division lessons, hopefully it's that the decimals really don't matter a ton when it comes to multiplication and division. We mostly just get to ignore them, and that's not going to be different today. Division with decimals in the divisor is going to turn out to be very similar to division without a decimal in the divisor, minus one little extra thing we have to think about. So here's the big idea of the lesson. Let's say that I wanted to divide 53 and 27 hundredths by 9 tenths. The first thing I'm going to notice is that my divisor, the number I'm dividing by, has a decimal here. But the thing I can't stress enough is that this really doesn't matter a whole lot. Let me show you why. To show you, I'm going to give you the answer. And the answer is that this ends up equaling 59 and 18 hundredths with the 8 repeating forever. Now we're going to change this problem just a little bit. Instead of being 53 and 27 hundredths, let's make it let's make it 5 and 327 hundredths divided by 0 and 9 hundredths. And what we're going to see is that if I plug this into a calculator, and you can check if you want, it equals 59 and 18 hundredths with the 8 repeating forever. You probably noticed, and if you didn't, I'm going to point it out, that these two answers are exactly the same. Let's do another one. Let's say this time that I'm going to change the decimal, or the problem, to be 532 and 7 tenths divided by 9. Again, if I answer that question, I find out that this equals the same thing, 59 and 18 hundredths with the 8 repeating forever. So this is really cool. We have three separate problems with different numbers in them because of their different place values, but they all give us the same answer. And we're going to use this fact in just a second to make division with our divisor decimal really easy. But let's look at what's happening here. You're going to notice between the first problem and the second problem, we've taken our decimal and moved it one place to the left. And that's actually true in both the divisor and the dividend. Both of them were moved one place to the left so that it became 10 times smaller. It was kind of like we just divided both of them by 10. If you look from the second to the third, you're going to see that what we did is we took that decimal and actually moved it again, but this time 2 places to the right. Again, both in the divisor and the dividend. And this is kind of the root of the idea. If we do the same thing to both our dividend and our divisor, it doesn't change the answer that we end up with. No matter how much we moved our decimal in these three problems, whether it was a bigger decimal or a smaller decimal, we ended up with the exact same answer, provided we did the same thing in both the dividend and the divisor. And the reason this works is because it's basically like multiplying or dividing the number by the same power of 10. So for example, the first one was like we divided both of them by 10 before we got to the second. And from the second to the third, it's like we multiplied them both by 100. If you want to think about it in terms of equivalent fractions, because we've done the same thing to both the top and the bottom, because remember, a fraction is just like a division problem. Because we did the same thing to the top and the bottom, whether it was dividing it by 10 on both top and bottom, or multiplying it by 10 on both the top and bottom, or by 100, we end up with an equivalent fraction, so it doesn't change the value. So what we learn from this is that we can play with our decimal, move it around as much as we want, provided we move it the same amount in the numerator and the denominator, the same amount in the dividend and the divisor. And now we're going to talk about why this is such an awesome thing. And I'm going to show you with a problem. Here I have 56 and 22 hundredths divided by 6 tenths. And this feels a little bit weird, again, because it's got this decimal in the divisor place. We know we get to more or less ignore the decimals and the dividends, but wouldn't it be nice if instead of dividing this by a tenth or 6 tenths, we were dividing it by a whole value? Well, based on what we just talked about, the nice thing is that we can. Provided I move the decimal the same amount on both sides, I can change these numbers as much as I want. And the way I'm probably going to want to change this is to move the decimals one place to the right so that this is no longer 56 and 22 hundredths divided by 6 tenths, but is 562 and 2 tenths divided by 6. That decimal would live, by the way, right there to the right, but I don't need to put it in at all because it's just a whole number now. And I'm really happy with this idea because now I'm just dividing by a whole number. Life is really easy in that respect. And we know that we're going to get the same answer because we've moved the decimals the same amount in both the dividend and the divisor. So I can just go ahead and solve this. 6 going into 562 and 2 tenths will get me the same answer as the problem I was originally trying to solve. So 6 doesn't go into 5. 6 goes into 56 9 times, which is 54, so there's 2 left over. 6 goes into 22 3 times, which is 18, so there's 4 left over. 6 goes into 42 7 times, and I just bring my decimal up like I always have, and I'm done. Nothing else to consider at that point. We make our change to our problem. We know we're going to get the same answer. We just solve an easier version of the same problem. For those of you that like a couple of examples, we'll do 2 more. So in this first problem, we are looking at 7 tenths going into 2 and 52 hundredths, or 2 and 52 hundredths divided by 7 tenths. Again, I don't really love this decimal in the divisor. It would be nice if I got rid of it, so I will. I'm going to take my decimal, I'm going to move it one place over so that now I'm dealing with the whole number 7, not 7 tenths. And to match, so that the problem ends up being the same, I'll do the exact same thing over in my dividend. So I'm eliminating that decimal from the divisor, making it easier to solve. So then I can just say 7 goes into 2, 0 times, with 2 left over. 7 goes into 25, 3 times, which is 21, so there's 4 left over. And 7 goes into 42 6 times with nothing left over, and I'm done. Last thing is to just bring that decimal straight up to where I had moved it, from where I had moved it to. So my answer for that one is 3 and 6 tenths. The same thing actually goes for this next problem. There is no decimal in my dividend, but I did want to show you that this works, in lots of different ways. 40 is a pretty big number. Maybe I don't want to deal with the number 40. It has a decimal that lives here. I could knock that 0 off by moving the decimal 1 to the left. So long as I do that on both sides, that's totally fine. And I can think of this now as being 4, not 40, which maybe will be an easier division problem to solve. So 4 doesn't go into 4 doesn't go into 1. I'll do this long form for those of you that do it long form. There's 1 left over, bring down the 5. 4 goes into 15 3 times, which is 12. So there's 3 left over, bring down the 2. 4 goes into 32 8 times, which is 32. So there's nothing left over, bring down my 4. 4 goes into 4 once, and again there's nothing left over. Same thing as before, I'm just going to bring that decimal up from its new position where I moved it to, and I'm done with my problem. Hopefully that all feels pretty manageable. If I was going to stress one thing, it's that we really have a lot of kind of playing around that we can do with the decimals. So whenever you encounter decimals in the divisor, the easiest way to handle it is just move those decimals so that you get to a whole number instead of having to deal with that decimal divisor. And you can do that as much as you want, so long as you remember to do it in the dividend as well. Also, a good thing to note in this final example here that we don't just have to move it once. We can move it as many times as it takes. So if I'm looking at 9/100ths, I might jump it 2 places, again on both the divisor and the dividend, to make it 9 wholes. So I can move it as many times as it takes. So here are your practice problems for the lesson. For each of these, you're going to need to set this up correctly. You can change the problem so that your divisors are whole values. Just make sure you do the same thing to the dividend. And that's pretty much it. Good luck.